Hey, what's good, geometry? Mr. Walker with you. We are going over the final review for geometry. So, what I'm going to do is I'm going to bust this up over 4 videos. There are 28 problems total, so 7 problems per video. That way, I'm not making one insanely long video, and that way you can kind of isolate what exactly you're looking for or what exactly you're having trouble with. Okay, so number 1, we're going to solve each proportion for the variable. It's just a matter of cross multiplying. If I had my drawer, that'd be good right there. Now that negative and the negative 3/4, we got to be a little bit careful with that. That doesn't mean both the 3 and the 4 are negative. Pick one of them and make it negative. I'm going to make that negative 3 my negative number. So 7 times negative 3 equals 4 times n plus 1. And from here, it's a matter of distributing and multiplying and just using algebra. So negative 21 equals 4n plus 4. Subtract 4 from each side. And you're left with negative 25 equals 4n. Divide each side by 4. And you get n equals negative 25 over 4, which I believe is equal to negative 6 1/4. Yep, negative 6.25. So if you want to leave it as a fraction, you can. If you want to put it as a decimal, you certainly can. Either one is fine. Number 2, using proportions, solve for x. Here's how I'm going to do this one. I'm going to focus on this triangle, and I'm going to put that number on the top. So 5. I'm going to use this side because we know that side. 5 over. Now what goes on the bottom? What goes on the bottom is the longer side here. To find that, you just take 5 plus 3 and you get 8. So we have 5/8 equals. Now I'm going to do the same thing. Maybe I'll draw this one in purple. I'm going to do the same thing for the purple triangle. So start with the shorter side. 2x plus 2 over. Now what's the longer side? Similar to how we found the longer side for the other side, you take 2x plus 2 plus 6. Just combine like terms. 2x plus 8. Plus 8. There we go. So 2x plus 8. There we go. And from here, cross multiply. So we have 8 times 2x plus 2 equals 5 times 2x plus 8. Distribute on both sides and then just use algebra. So we have 16x plus 16 equals 10x plus 40. Here's how I'm going to do this. I'm going to subtract 10 from both sides, and I'm also going to subtract 16 from both sides. So those go away, those go away. So we're at 6x equals 24. Divide each side by 6, and you're on the home stretch. So x is 4. All right, where's my mouse? There it is. Number 3, solve for x. And they give us a handy bit of information for number 3. They tell us that the polygons are similar. So how does that help us? We use proportions once again. So this side and this side correspond with one another. So 15 over 4x. Whoops, I did it again. This is actually take 2 on this video because I made the exact same mistake in the last take that I did. Minus 4. I get too carried away sometimes. So 15 over 4x minus 4. Now you got to figure out which other side corresponds to the 18. Is it the 28 or the 24? To kind of help you out, rotate your paper and kind of compare the triangles. You'll see that this 18 and this 24 correspond. 18 over 24. Here's a bit of advice. How I would go about solving this one, you could certainly start cross-multiplying, but you're dealing with double-digit numbers, and those are going to get really big. What I would do is I would reduce the fraction on the right, 18 over 24. So we have 15 over 4x minus 4 equals 3 over 4. That's much easier. Smaller numbers is easier multiplication. So we have 4 times 15 equals 3 times 4x minus 4. So that's 60 equals 12x minus 12. You add 12 to both sides, you get 72 equals 12x divided by 12, and you get x equals 6. And that's how you do number 3. We're going to go ahead and scroll down to the next page, jump right in with number 4. Use the geometric mean to find the missing length. Here's how you go about doing this one. You have x over 12. So in other words, you've got kind of the hypotenuse-ish side looking of the bigger triangle. Put that over 12 equals 12 over 9. Cross multiply. Or you could go ahead and reduce on each side if you wish. Maybe I'll show that over here. Equals 4 over 3. And then you could cross multiply those. In either case, you'll get the exact same thing. I'll show the work for each real quick for what you should get. So x is 16 over here. Here you get 3x equals 48. X still is 16. Either way you want to approach it is fine with me. You'll get the same answer. Number 5, use the Pythagorean theorem. Find the missing side, the good old Pythagorean theorem. If you're not sick and tired of it at this point, then congratulations. Okay. This is a good old a squared plus b squared equals c squared, where c squared is our hypotenuse. Remember, if you don't remember what the hypotenuse is, it's your longest side. Or, the way I think about it, you see that right angle symbol? Our hypotenuse never touches that right angle. The sides that do touch that right angle are our legs, or our A and B. So let's go ahead and start cracking at it. X squared plus 8 squared equals 16 squared. X squared plus 64 equals 256. Subtract 64 from both sides. X squared is 192. Here's where it gets a little tricky. You need to take the square root of each side. Here I'm looking for the exact value. So that means I need to reduce that square root. That means you need to play around with your calculator, see if a perfect square divides into 192, and you should find that the largest one that does is 64. 64 times 3 is 192. Square root of 64 is 8. So you have 8 square root of 3, and don't forget your units, 8.3 or 8 root 3 miles. All right, number 6 and number 7, here we go. Here, we want to see if we can use special right triangles. We want to leave our answers as radicals in simplest form. And then if we have fractions, we can't have radicals in the denominator. So right on the left here for number 6, I actually have a 30, 60, 90 triangle. And if you took a look at the answer key that was uploaded, you'll see that I actually drew a little picture. So I'm going to say that's my 60-degree angle and that's my 30-degree angle, even though it doesn't really look like it. So this side would be x, this side is x root 3, and this is 2x. Now how does that help us? This x and this 2x, to find x, I just divide the hypotenuse by 2. In other words, y is 8 divided by 2, which is 4. And x is simply whatever this side is times the square root of 3. So 4 root 3. And there you go, special right triangles. Really, they do come in handy. Number 7, I have a 45, 45, 90 triangle. So that's a 45-degree angle, that's a 45-degree angle. So our legs are x and x. Our hypotenuse is x times the square root of 2. Now, there's a number in front of that square root of 2. It's understood to be 1. So that means x and y are the same. They're 1. X is 1, y is 1. How did I get that? Normally, how we find that hypotenuse or how we find our sides, if they give us something for the hypotenuse, we usually divide that by the square root of 2. Here, it's root 2 divided by root 2. That's where I'm getting that 1 from. So there you have it. That's numbers 1 through 7. Thanks for tuning in. We'll see you in the remaining videos. Happy studying.